Okay, this video is for page 3 of the study guide. So, in this case, in this car, this illustration up here, they have a car going at 5 meters per second. It hits a brick wall and bounces off, and then it's going 4 meters per second in the opposite direction. And then down here, case B, a car going 5 hits the brick wall and crumples up and doesn't move. And so what they want to do is they want to know the change in velocity. They want to know which one's greater. So if we look at it just in the total magnitude of the change, if you take what it was going at the beginning, so for this would be car A, it's going 5 meters per second, but then you're going to take the difference, then it's going 4, but it's going in a negative direction, so that's 4 meters per second. So 5 minus a negative 4 is basically adding. So if car A is going to change its velocity by 9 meters per second. Now we're not gonna worry about the sign here for this class, but if you were taking a different, like higher level physics, we'd have to worry about whether that's positive or negative. Anyway, in this class, here's car B. Okay, so car B, all right, so it's going at 5 meters per second, but then it's going at 0. So 5 minus 0 equals 5 meters per second. So what you can see is that car A has the bigger change in velocity. All right, so anyway, now we can go down here. So in which case does car A or car B have the bigger momentum change? Well, remember that momentum equals mass times velocity. So because car A has the greater velocity, it's going to be the one because A has the greater velocity. All right, so anyway, and because it has the greater velocity, if we plug that number in, if the v is bigger, the total momentum will be bigger, the velocity. Okay, number 6. A 6-gram bullet is traveling 350 meters per second, is brought to a stop by a wall in 0.0018 seconds. How much force did it take to stop the bullet? Okay, this equation will be on the board for you. So force is going to be equal to mass times velocity over time. So what we're going to do is we're just going to plug the numbers in. So we're going to take the mass, but the one thing, the grams, we always have to work in kilograms. So you're going to have to take 6 grams, and then 1 kilogram equals 1,000 grams. Remember, I have the grams diagonal from the grams, so they cancel out. So 6 times 1 divided by 1,000, that's going to equal to 0.006 kilograms. I'm running out of room there. All right, so we're going to plug that in. So we're going to go 0.006 kilograms times the velocity, 350 meters per second. We're going to divide that by the time, 0.0018 seconds there. And so then the force, if you do that math, multiply the top, divide by the bottom, it's going to equal 1167, and the units would be a Newton. Okay, it'd be a kilogram times a meter per second squared. That's a Newton. So just remember that a force is a Newton unit. Okay, number 7. According to the Guinness Book of World Records, the fastest recorded baseball pitch was delivered by Nolan Ryan. The pitch was clocked at 100.9 miles per hour, which is 45 meters per second. Determine the impulse required to give a 0.145 kilogram baseball such a momentum. So remember that impulse is equal to force times time. So impulse is going to be equal to the force, okay, times the time. Let's see here. So what we can do is we could also remember that impulse is equal to mass times velocity. And so basically we end up getting that the mass times the velocity will be equal to the impulse. So what we can do is we can just take the mass, so 0.145 is, impulse equals 0.145, that's going to be kilograms, and we're going to take that times the, let's see here, that's going to be times the change in velocity, which is 45.0 meters per second. So let's see, that equals 6.5 kilograms meters per second. So that's what the answer would be. That's the change in the momentum times the velocity, basically. So that's going to be what the impulse is. So, all right. Okay, that's it for page 3.